All right, guys, are there any questions over any of the homework assignments thus far?
No, sir.
So, what we're looking at today is synthetic division. What we're doing today is synthetic division. So, when we look at this here, there's a few main steps for doing synthetic division. Synthetic division is going to give us the same results as if we did it by long division, but I have a feeling y'all are going to like synthetic division more. Now, the first thing we do is we take what we're dividing by, set it equal to 0, and solve for the biggest variable. So we're going to solve for m. So if we're solving this for m, the first thing we need to do is m equals 3. Any questions on this so far? Okay. So the first thing we do is solve this for m. Now we set this up. So to set up synthetic division, the first thing we're going to make and draw is a cubbyhole and a line. Now the value we solve for m, or the variable here first, goes in the cubbyhole. So 3. Now the next thing we do is across the top, we're going to take all the coefficients from the variables here. All the numbers in front of the variables, and if there's a variable missing, we put it in a 0. So m to the third, what's the number in front of m to the third? 1. The number in front of m squared? Negative 13. The number in front of m, and our last number is 18. So we've set this up. Questions on this so far? Okay, now we're going to start synthetic division. And the first step is to bring the first number down. So you bring it down below the line. Okay. I'm going to be drawing a bunch of arrows. If y'all were you, I wouldn't draw them in because there's going to be a lot of arrows and stuff going on. So the first thing we do with synthetic division is we multiply the 3 by the number down here. So we would have 3 times 1, which is 3. We take this 3 here and put it under the next number. We're good with this so far. Add straight down. Negative 13 plus 3. So we'd have negative 13 plus 3 is negative 10. Okay? Question so far? Then we're going to multiply negative 10 by 3. So we have 3 times negative 10. We put it under the next number. Add straight down. Negative 30 plus 24 is negative 6. Multiply again. 30 times negative 6 is negative 18. Do we have another number after that, guys? Face forward. I always box the last number for these here. That is our remainder. So this here is our remainder. Now we fill in back in. Now, you don't have to put this in here because the first one here would be negative 6 times m to the 0. Well, anything to the 0 exponent is 1. So we really don't have a variable there. Then we increase it by 1. So we would have m to the first, because m to the 0, then m to the first, and then it would be m squared. So really what we have is m squared minus 10m minus 6. We're done. Any questions on this here? And that's it. That is synthetic division. You ready for the next one? Okay, so we look at this one here. The first thing we need to do is solve v plus 4 for v. So we said v plus 4 equals 0. So v is equal to negative 4. We would put negative 4 up here. So our number's across the top. So we're starting with 8, and then 0, because we have v to the 5th, yes? So we need them all. So v to the 4th would be next. After v to the 4th would be v to the 3rd. Do we have a v to the 3rd? So we have to put it in as 0. After v to the 3rd, we would need v squared, which is another 0. After v squared, we have v to the 1st, or just v, which would be 5. And then our last number is 20, because if there's any of them missing, we've got to put them in as zeros. Now this one here does work out very nicely, because here the first thing we need to do is to drop the 8. Try that again. 8. Now our first step is to multiply by 4, negative 4. So we'd say negative 4 times 8. And negative 4 times 8 is negative 32. And we'd put it under our next number. And then we'd add straight down. 32 plus negative 32 is? Our next multiplication is negative 4 times 0. Okay, 0. 0 plus 0 is? Negative 4 times 0 is? 0 plus 0. Negative 4 times 0 is? 5 plus 0 is? 5. Okay. Now we have something different. Negative 4 times 5 is negative 20. And negative 20 plus 20 is 0. And I always box the remainder. Now, because we're dividing by a binomial, a 2-term, we should only have one remainder value. If it had been, instead of 2 terms, it had been 3, we should have 2 remainder values. Now, when we plug the variables back in, so this here is our remainder. Our 5 is our constant term. It doesn't have a variable. The number after it would be v squared, v cubed, and then v to the 4th. So our final answer is what? AV to the 4th plus what? 5. Because 0v cubed is just 0. 0v squared is 0. 0v is 0. All of these become 0, so we're just left with 8v to the 4th plus 5. If it's 0, we don't have to put it back in. Questions on this here? Questions on any of this here so far? You ready for the next one? What's different about this one here? 3 in front of the x. Whenever this biggest variable here has a number other than 1, we have to divide the entire thing by that number. So that means I'm going to end up dividing this by 3, this by 3. But we also have to divide all of these by 3. So what we actually have is, well, 3x cubed, guys, 3x cubed divided by 3, x cubed. Does 4 divide by 3 nicely? No, so we'll leave it as 4/3 x squared. Does 17 divide by 3 nicely? No, so we'll leave it as 17/3 x plus 2. Divided by, well, 3x divided by 3 is going to be minus. So whenever that number in front of x, or that biggest term, is not 1, we've got to divide everything by that number. Now the rest of the process is going to be the same. So we do take the x minus 1/3, set it equal to 0, and solve. So we would add 1/3 to both sides, guys. So here x is equal to 1/3. So the number that goes in the cubby hole is 1/3. The numbers that go across the top are going to be 1, -4/3, 17/3, and 2. Drop the 1. Now we start this process again, so we'll do 1/3 times 1, which is 1/3. So we can put the 1/3 here. Now the next thing we'll need to do is add -4/3 and 1/3. -4/3 plus 1/3. Well, the denominators are the same, yes? So we can add the numerators. -4 plus 1 is -3. Now we can multiply. 1/3 times -1 is, well, -1/3. Now we add these two together. And again, you could add these in a calculator, -17/3 plus -1/3, and it's going to give you -6. Minus 1/3. Since the denominators are still the same, we have 3. 17 minus 1 is -18. Negative. 18 divided by 3 is 6, and it would be negative. Then lastly, we do -6 times 1/3, which would be -6/3, which is -2. So lastly, 2 plus -2 is and that is our -6 is the term without x. The one next to it is the term with x, and the one after that is the term with x squared. So our final answer is what? X squared minus x minus 6. Any questions on this here? So the degree of what we're dividing by, so our 3x minus 1, the degree is what? 1, yes? The degree of what we started with was 3, yes? When we divide, where essentially we can say we subtract the degrees. So the degree of what we started with is 3, what we're dividing by is 1. 3 minus 1 is, what was our answer's degree? It works that way every time. Because if we look at the previous one, the degree of what we divided by is 1, yes? What we started with was 5. 5 minus 1 is 4. The degree of our solution is 4. If we looked at the ones we did yesterday where we had a quadratic as our divisor, what we were dividing by, it would decrease the degree by 2. Any questions on this here? Any question over anything we've done so far? Let's look at this one here. I have a feeling y'all have gotten the hang of this. So the first thing we're going to do is set x plus 1 equal to 0 and solve for x. So we would subtract 1 from both sides, telling us x is -1. So -1 goes in the cubbyhole. Across the top, we would have 3, -2, 2, and -5. And we bring down the 3. Any questions on this so far? Now, all the calculations that we're doing for this year, you can do it in the calculator. As we could do in the calculator -1 times 3, which is -3. Then we can do plus -2, because -3 plus -2 is -1 times -5 is +5, yes? 5 plus 2 is 7. -1 times 7 is, and -5 plus -7, guys, here is -12. Questions on this here? So we plug the variables back in. This would be our remainder. 7 would be our constant term. 5 would be our term with x, and 3 would be our term with, so we have 3x squared minus 5x plus 7 plus, how did we do the remainder or write the remainder yesterday? So we'd have -12 on top, yes? And what would go on bottom? So what have we been dividing by? Well, what did we divide by? X plus 1, yes? It's still the x plus 1. We use the -1 as a part of our synthetic division to get there, to make it easier to work. But we're still dividing this polynomial by x plus 1. Questions on any of this here? We good with all this here so far? Okay. Do we need to see another example of synthetic division? You feel comfortable with this here? Okay. So we'll skip ahead to this here. So it should say example 4 at the top of your page. This one here, we want to evaluate the function using synthetic division. Now, we've evaluated functions already. We did this on Tuesday. Because on Tuesday, when we evaluated a function for a given value, we just took that number and plugged it in for x. In every place, plugged it in the calculator, hit enter, and got a value. Yes? So what we want to do this time is we want to use synthetic division and see how, if any, of these two will connect. Now, they already told us x is -4, yes? So the number that goes in the cubbyhole is -4. They already gave us that value. We don't have to go and find it or solve for it. Now, the numbers are going across the top are going to be 5, -1, 13, and 29. Guys, first thing we'll do is bring down the 5. And then we will multiply. -4 times 5 is -20. and we'll put it underneath there. Then we'll add straight down. Negative 1 plus negative 20 is negative 21. Then we'll multiply by 4. Negative 4 times negative 21. Almost. It's just 84. Negative and negative. Negative 4 and negative 21 is 84. Then we would add straight down, which gives us 97. Then we multiply 97 by negative 4, which will give us negative 338 or 88? 88. And at this point here, again, we'll add straight down, which will give us 359. Okay. And that's what we got as our remainder, yes? Okay. Now, on Tuesday, when we evaluated, we essentially plugged negative 4 in for every x spot. And doing this here would give us the value for this function. That's how we evaluated it on Tuesday, yes? And we get a value of? What was our remainder? Negative 359. So the value of the remainder, and when we evaluate it, are going to be the same. The value of the remainder, and when we plug that number in for x, are the exact same. So that seems kind of interesting, and it is actually very helpful, because if we know when we divide two numbers, if it divides evenly, the remainder is what? So if I evaluate a function for a given number and I get 0, it means it goes into it evenly. It means it's a solution. It is a factor. So if the remainder is 0, we know it's going to divide evenly. So this kind of gives us a way to know that that value is a solution if it gives us 0. Let's do one more of these. So they told us x is 5, so 5 goes in the cubbyhole. Across the top, we'll have 4 for x squared, negative 10 for x, and negative 21. And almost, once we get good at these here, you can almost do these by synthetic division as fast as you can probably plug them in. 5 times 4 is? Negative 10 plus 20 is? 5 times 10 is? Almost. So y'all can add up, especially for these here. So for 1 with 21, if I add 9 to it, I would get 30. And then with the 3, I would add 2 to get 50. So 29. Questions on this here? And we would know that 29 is positive because 50 was the bigger number. Any questions on any of these here? Okay. I did skip this one. Now, I'm going to show you how to do this. But these here, especially when I learned these in high school, our teacher just told us that we need to do these by long division. And again, doing these by long division is a little bit simpler, but we can still do it by synthetic division. I ended up looking these up after teaching here for a few years because I had a student ask me, can we do a problem like this here, or what we're dividing by, the x squared minus x minus 4, where we don't have a binomial, we don't have two terms. Can we still do it? At first, my instinct was no, because I'd never seen it. But again, I stopped. I did go back and research and see, and it is possible to do this by synthetic division. It's just not standard practice to teach it that way. Now, it's not because it's overly difficult or challenging. There's a few more steps involved. Now, the first thing we do, just like with synthetic division or with a binomial, we solved it for x, yes? Here, we're not going to solve it for x. We're not going to get x by itself. We're going to get x squared by itself. So here we can set x squared minus x minus 4 equal to 0. So we're just wanting to get the x squared term by itself. So the first thing we can do is add 4, which tells us that we have x squared minus x is equal to 4. And then we can essentially, we wanted to get everything on one side and x squared on the other. So if we had x cubed as the biggest term, we would get the x cubed term by itself and move the x squared x in the constant term to the other side. Any questions on this here? So, I mean, we've had one more step, nothing too bad. So now we can set this up. So we'll have our little cubby hole. Now, you can put the two numbers if you want to put kind of little dotted line there to split it apart. Because inside the cubby hole now, we're going to take the coefficients from this here. So the number in front of x is, and the other number is 4. So we'll have two numbers here instead of just one. That's one of the main differences between having a binomial to a trinomial, because now we have two. It's just a 1 and a 4. Yep. I put the little dotted line there just so, as a reminder, that it's not 14, it's 1 and 4. Now in the previous one, we had a line. Yes? We had one number in the cubby hole, so we have one line. Now we have two numbers in the cubby hole, so we're going to have two lines. Questions on this so far? Now, the next part's going to be the same. We're going to take all the coefficients from here and put them across the top. So we'll start with 2, and then we'll have 1 for x to the 4th, and then negative 15 for x cubed, negative 2 for x squared, 10 for x, and then negative 24. Any questions on any of this here? Okay. Now our first step in doing all the other synthetic divisions was to bring the first number down, yes? So again, we're going to do that, but we're going to bring it all the way down. And we'll also bring the second number down. So we bring the first number to the very bottom, and for this one here, we bring the second number partway down. If we had, say, 3, a cubic, so we had 3 numbers there, we'd bring the first one all the way down, the second one down 2, the third one down 1. So we get this kind of staggered step. Any questions on this so far? Now our first part of synthetic division was to multiply that number by the bottom one, yes? Same thing here. So we're going to say 1 times 2. And we put it right here. Now with the 4, we're still going to multiply it by that same bottom number. 4 times 2 is, but this time we put it all the way up here. Questions on this so far? Add straight down. So here, 1 plus 2 is, up here, negative 15 plus 8 is. Repeat the process, now we're multiplying it by the 3. So we do 1 times 3 is, 4 times 3 is, add straight down. Negative 7 plus 3 is, negative 2 plus 12 is. We repeat the process. 1 times negative 4 is, 4 times negative 4, negative 16. Questions on this here? Add straight down. 10 plus negative 4 is 10 plus negative 16. Do it again. So we'll have 1 times 6 is 4 times 6 is. Now we add straight down. 6 plus negative 6 is. Negative 24 plus 24 is. Now in all the ones we've done previous, how many remainder values do we have? 1. How many are we going to have here? 2. So these two here are our remainder values, yes? And with our normal one, so we had one remainder value, the number next to it was our term without x, then the term with x squared and going up. With the remainders, it kind of works the same thing. This is our constant. This here would be our term with x, our remainder with x. But they're both zeros, so it doesn't really matter. Outside still works the same. 6 would be our term without x. Negative 4 would be the term with x. 3 would be the term with x squared. And 2 would be the term with x cubed. Which tells us that our final answer is 2x cubed plus 3x squared minus 4x plus 6. Now there's our final answer. So it is possible to do this with synthetic division. There's a little bit more going on. So if you prefer or like doing these here, where what we're dividing by is a quadratic by long division, you want to do it that way. Both will work. This year we do have to make sure we set it up correctly and we're keeping track of more numbers, but they both work the same. And that is it. Our homework is on page 187, problems 12 through 18, 23, 25 through 28.